The topic under discussion is black box testing. So let's learn something about what is black box testing. It is a software testing technique in which the tester does not have access to the internal workings of the system or application being tested. The tester only has access to the inputs and outputs of the system and must test the functionality and behavior of the system without knowledge of its internal code. This type of testing is carried out in series of steps which are as follows. The first step is based on a specification of requirements, so it is examined in the beginning. In the second step, the tester creates a positive test scenario and also an adverse test scenario by selecting valid and invalid inputs to check the software is processing them correctly or incorrectly. In the third step, the tester develops various test cases such as decision table or weight test, equivalent division, error estimation, cause effect graph, etc. The fourth phase includes the execution of all test cases. In the fifth step, the tester compares the expected output against the actual output. In the final step, if there is any flaw in the software, then it is cured and tested again. So, what is the purpose of black box testing? The primary goal of the black box testing is to evaluate the functionality of a system or application without any knowledge of its internal working. The tester only has access to system inputs and outputs and is unaware of the internal algorithms or code used to produce those outputs. Black box testing also helps to verify that the system or application works correctly with different inputs and under different conditions. This includes testing for boundary conditions, invalid inputs, and unexpected user behavior. By performing this type of testing, black box testing can help to ensure the quality, reliability, and functionality of the software system. So here is a comparison of the two testing techniques. In the black box testing, the implementation of code is not needed for the testing, but in the white box testing, code implementation is necessary. In the black box testing, the time consumed is more, whereas in the white box testing, the time consumed is less. It is not suitable for preferred for algorithm testing, whereas white box testing is suitable for algorithmic testing. The black box testing technique is mostly done by software testers, whereas white box testing is mostly done by software developers. So here are some types of black box testing. The first type is functional testing. This is a type of testing technique which is related to the functional requirements of the system. Functional testing is concerned only with the functional requirements of the system and covers how well the system executes its function. Regression testing. Regression testing is performed after code fixes, upgrades, or any other system maintenance to check the new changes has not affected any existing functionality. Non-functional testing. This black box testing type is not related to the testing of specific functionality. Non-functional testing is concerned with the non-functional requirements and is designed specifically to evaluate the readiness of a system according to the various criteria which are not covered by functional testing. So let's discuss some advantages of black box testing method. The first advantage is objective evaluation. Black box testing provides an objective evaluation of the system's behavior from an external perspective without any bias or assumptions about the internal working of the system. Emphasis on user experience. Black box testing focuses on the user experience, ensuring that the system performs as expected and meets the requirements of its intended users. Wide coverage. Black box testing can help ensure that all features and functionalities of the system are tested regardless of whether they are visible or not. As we all know, everything has pros and cons. So is black box testing. So here are some disadvantages of black box testing. Limited knowledge of system internal. Black box testing does not provide insight into the internal working of the system, making it difficult to pinpoint the root causes of the issues that arise. Repetitive testing. Black box testing can be repetitive, with testers needing to input data manually to cover all possible input scenarios, which can be time consuming and tedious. Difficulty in identifying complex issues. Black box testing may not identify complex issues that require knowledge of the system's internal working or code. So there are certain types of defects that can be detected by black box testing. The first defect that can be detected is incorrect or missing functionality. Black box testing can detect defects where the system is not performing as expected or is missing a required functionality. The second defect that can be detected is input-related defects. This technique can detect defects where the system fails to accept valid inputs or accepts invalid inputs. Performance-related defects. Black box testing can detect defects related to system performance, such as slow response times, system crashes, or other performance issues. Interoperability defects. Black box testing can detect defects where the system does not work correctly with other systems, applications, or services, leading to compatibility issues. Data format related defects. The test case for black box testing are as follows. Identifying the requirements. The first step in the test case design for black box testing is to identify the system requirements. This includes functional requirements, non-functional requirements, and any other requirements specified for the system. Identify the inputs and outputs. Once the requirements have been identified, the next step is to identify the inputs and expected outputs for each requirement. Determine test coverage. Test coverage refers to the percentage of the system that will be tested. For black box testing, test coverage is typically determined by identifying the critical functionality and areas of the system that are most likely to have defects. Prioritize test cases. Once the test cases have been designed, they should be prioritized based on their importance and the likelihood of uncovering defects. High priority test cases should be executed first, followed by lower priority test cases. Execute the test cases. The final step is to execute the test cases and record the results. The results should be analyzed to identify defects and to determine whether the system meets the specified requirements. Test case design for black box testing involves identifying requirements, inputs, and expected outputs, designing test cases to cover all possible scenarios, and prioritizing and executing the test cases to uncover defects and ensure that the system meets the specified requirements. So there are various black box testing techniques. First among them is equivalence partitioning. These techniques involve dividing the input domain into equivalence classes or partitions and selecting a representative input from each partition to test the system's behavior. Boundary value analysis. This technique involves testing the system's behavior at the boundaries of the input domain where errors are more likely to occur. Test cases are designed to test the system's response to the minimum and the maximum values of the input domain. The next testing technique is decision table testing. This technique involves designing a table that captures all possible combinations of inputs and their corresponding outputs. Each cell in the table represents a test case that needs to be executed to test the system's behavior. State transition testing. These technique involves testing the system's behavior in response to different transitions between states. Test cases are designed to test the system's behavior when it moves from one state to another. So let's consider some examples of black box testing in real world scenarios. The first scenario that we're considering is banking and finance. Banking and finance applications undergo rigorous black box testing to ensure that they meet strict security and compliance standards. Testers use techniques like boundary value analysis to ensure that the application can handle large amounts of data and error guessing to identify potential security threats. One more example is healthcare. Healthcare applications must be tested thoroughly to ensure that they meet strict regulatory standards and ensure patient safety. Testers use techniques like decision table testing and error guessing to ensure that the application functions as intended and is free of errors. So let's discuss upon the tools used for the black box testing. Selenium. It is a popular open source tool for testing web applications. It can simulate user actions and automate testing of user interfaces, making it easier to test web applications without having to write to code. Appium, an open source tool for testing mobile applications. It allows testers to write tests in various programming languages and can be used to test both Android and iOS applications. JMeter. It is an open source tool for load testing web applications. It can simulate large number of users and test the application's performance under heavy loads. Postman is an API testing tool that can be used to test RESTful API. It allows testers to send requests to an API and verify the responses, making it easier to test the functionality of an API. So, why black box testing is important? Here are some points that covers the above heading. The first among them is uncovering defects. Black box testing can help uncover defects and vulnerabilities in software applications that may not be apparent through other testing methods. By testing the software from the end user's perspective, the black box testing can identify potential issues that may not be visible to the end developer, enhancing user experience. Black box testing can help ensure that the software applications are user-friendly and provide a positive user experience. By testing the software from the end user's perspective, black box testing can identify potential usability issues and ensure that the software is easy to use and understand.